his name is Brian Staes. Is it Staes?
Staes.
Okay. Okay. Brian is a graduate research assistant at the Center for Urban Transportation Research under the supervision of Dr. Robert Bertini. He is currently working on a large-scale evacuation highway performance standards. He graduated from Florida Gulf Coast University with a bachelor's degree in civil engineering in 2018. Is currently pursuing a master on transportation from University of South Florida.
Thank you, Matt.
All right, thank you.
Okay, hi everyone, how are you? I'm Brian Staes, like Matt said, and today I'm going to show you some unique visualizations that I came up with myself using archived real-time public transportation data from two sources. So here are the agencies that I was able to get data from. One is HART, Hillsborough Area Regional Transit Authority in Hillsborough County, Florida, and then also the USF Bull Runner. Again, same county, and actually, I go to school here, so, okay. So this is the HART system. So it's located in Hillsborough County. It has approximately 200 natural gas buses, but I think it's like more like 180, but we'll round up. Operational area of 1,000 square miles, so it's covering actually a very large area. Route configuration is 26 local, 7 express. You can see the local ones are all the brown right here. 7 express, these are the purple right there, and then we have 5 Amflex, 1 BRT line, and they actually have a heritage streetcar. I was going to put an image of it. It looks pretty cool. It's like historic, and everyone likes to ride that. And typical daily ridership of 37,000. So this is the HART. This is the county level transit. And then now we have the Bull Runner system. So this is, again, just for my university campus. We have 3 circulators and then 2 off-campus shuttles, basically, that go around the campus. And then we do have 1 connection to the HART University Area Transit Center, which is the furthest point on one of the routes for HART. So there's a connection between the university shuttle system and the county level transit system. And then in the fiscal year 2017-18, we had 900,000. So it is a fairly large, a lot of students use it. And then bottom left is just like a little graphic of some previous work that I've done, but we don't need to get into that. And then right here, this is actually, I couldn't really find a decent map that I wanted to use for the Bull Runner, so I just created an interactive map in Tableau. Like you could click on all this stuff and figure out the ridership and the days and stuff like that. But that's not really the point of this. I just wanted to have a map. Okay, so the type of data itself, it's AVL-APC, so automated vehicle locator and then automated passenger counter, I'm sure you all know. The top data set that I'm predominantly going to be using is the schedule adherence. So as you can see, there's all types of variables in there. The variable list itself is actually quite long. It's like almost 100 variables. And so some of the interesting ones that I wanted to use myself were the delta, so the distance in feet from the calibration to the door. So like as a vehicle is decelerating, how long does it take for it to finally stop and open its doors? So you can figure out basically dwell times and things like that. You can see how much it's decelerating. It's interesting. The scheduled deviation time, which I'm going to be showing you some charts with this data right here. So that's just how close it is to the actual, the scheduled time versus when it arrives, basically. Again, we have dwell time, wheelchair and bike rack activity. So it's just like when was it deployed, when was it not deployed, where was it, and all that stuff. Maximum velocity of bus. So this one's actually quite interesting because this starts to take into consideration this distance in feet from the calibration. So these two are kind of like combined, but that's just the data. And then I'm just getting at the point that there's a lot more in this data set, and I just kind of dabbled with a little bit of it. So we're going to start with the Bull Runner data. So this is another dashboard I created. This is the blue is the passengers off in spring of 2017, and then the green is the passengers on. So the top one is off in spring, the bottom are on in spring, and basically the idea for the chart is if it's low availability, it's red. So I define availability here as the amount of routes that are intersecting each one of these stops. So this is one route intersecting one route, and then the big blue dots are like 6 routes that are all hitting. So it makes sense that this blue dot, it should be large because you have 6 routes interacting. So basically what you should get out of this chart is if it's red and big, you should pay attention to it because it has one route and you have a lot of individuals using that route. And again, this is also interactive as well. We could click on it and you could find out more little information about it. And this is done in Tableau. Okay, so the trajectory map. So I'm sure you guys have already seen tons of these before. And I mean, they're kind of interesting. You can see some transient, like for instance, this top one up here, it was actually identified that when they got to 40, 50 lofts right here, the bus was full, so they just deviated from their path. They went straight to the Marshall Student Center, so they skipped this route right here, and they skipped all the way to here. So that's why, it's one constant velocity. Makes sense. And then another one that you can use trajectory data for is right here. So this is actually the bus. It's taking a break. Like you just stop there, and you can see that. You can see what your drivers are doing. Trajectory data, you can see how fast the vehicle's going, where it's going, stuff like that. So it's interesting. So now we have ridership, where although we do have the trajectories, we can see how quickly they're going and where they're going. We don't necessarily know where's the ridership. So this is just springs on and off. Just, obviously the larger the dot, the more potent that spot is for ridership. And smaller, it's not as potent. But you can kind of see, okay, we have a year's worth of data basically here, and you can see what's the yearly trend. But although we do have this yearly trend and we have the trajectory data, how do we combine the two? So that's where we get to this. So this is basically a mixture of the occupancy of the bus going through time, and then also the speed of the bus itself. So basically, the steeper the lines, the quicker it's going. So you can tell here, like at about 10 o'clock, its occupancy is quite low, probably like 5 individuals, but it takes a while to get from this stop to that stop. And that's actually because if we track over here, this is actually a stoplight, so the bus had to stop for a while twice, and that's why, technically, if you can imagine a line connecting all the way through these cubes, that velocity is a lot slower. So you can see both the occupancy of the bus and then also the speed of it. And then more interesting too, what you can do with this. So if you say, all right, this is all green, right? This bus is predominantly empty most of the time. However, we get all the way up here and then all of a sudden it's red. So you're like, okay, well, that's obviously very interesting. We want that route to maybe send another bus at that location. And we see it continuously happening. Red, 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 black. So this is more or less a way to identify through time maybe where you should send an additional bus to pick them up and then come back to your to the stop. So this was the bull runner data. So I had access to this first, and I got to create a metric like this just to kind of test and see what I had. So now, when I finally got the HART data, which was the bigger data set, I want to say, okay, what does this look like? So here's the HART data. So, and one thing I should mention, the only reason why this is one continuous line and it comes back, I just said, this is the end of the line, and you come back. But here, because the route was a little bit longer, and it connected, like at the beginning it was at a transit station, and then this is also a transit station, I made it like a wishbone shape, just for preference. So again, the same thing here, you can identify, we have all of these stops, but the majority of the time, it's actually quite empty, usually on the bottom left side, you usually don't have that many passengers, and then when you start getting closer and closer to the stop at the top, which is the UATC transit, the area transit location, which is like the hub, basically, the furthest hub, you see it drop off dramatically, which is interesting. And you can also see too, in this time frame right here, you have this huge gap, right? So it's just basically sitting here waiting for its next go back to the original location. So again, you can imagine this, this were to be continuous, and if this were to be continually plotting, you'd be seeing these wishbone shapes, and you can basically identify maybe where you should send an additional bus just to pick up, some location where there's maybe a lot of ridership and some small segment, and you can bring them back to where you probably know where they're gonna go, because the drastic change right here, these people are going here. Okay, so that's the trajectory mixed with occupancy. So the last part of the data set that I got to mess with was the schedule time adherence. So like basically, the deviation from when you were, when the bus was scheduled to be there and how late it was. So in here I made the scale purposely, 0 is green, however, you can go negative, right? And sometimes being a little early is actually worse than being too late, because then people trying to make connections, they have to wait twice as long, almost. So I wanted to make sure that I included a negative. And the only reason why, so all of the little purple dots are actually the individual stops. So like all of these stops, that's these little purple dots. So the data set itself, the schedule time adherence, they only did it at 5 locations. because, I mean, it would be fairly difficult to do it at every single location because you would have to be monitoring, or you would need to have a scheduled time at all those locations. So in their data set, they only chose 5. And these happen to be, you know, the very first stop, the last stop, and then intermediate stops. So basically the way then to interpret this, at the Marion transit station, this is going through time. So at 0 meaning that there's no, you're right on time. But if you see what's interesting, you know, 7 to 8 a.m., it's red, meaning it's 10 minutes at least over time. And this data set, like I said at the top, so this is October the 7th through March 3rd. So this is actually, you know, about 6 months of average deviancy. So this is almost always late, basically. And you can imagine too, this doesn't necessarily need to be through 6 months. You could do this by day. You could even, depending on it, how accurate or how extensive your data set is, you could have this look like, you know, a curtain almost, as opposed to 5 individual locations. You could have it go all along your route if you wanted to look at your scheduled time adherence. So again, this is just two of the variables I looked at. One is just occupancy through time, and the other one is scheduled time adherence. The data set that I've been working with, the APC, it's really extensive. And to be honest, the agencies, they really don't go through them that much. Like, they only meet their minimum standards, and then they kind of just throw it away and they don't touch it anymore. So, you know, maybe if we can employ some of these, you know, visualizations, maybe it'll help them in the future. And yeah, thank you.
Yeah, thanks to all of our panelists. Are there any questions for Brian here? Some great work. Yeah, please.
Can you talk about how commonly available the automatic passenger count data is?
Well, we requested, I want to say, a year's worth of it, and it probably took a few months to get it, so probably not that available. But the agency themselves, if you're within the agency, it's there, like it's continuously tracking it. So
Those agencies
yeah, I
are
mean,
tracking. Do you have a sense of like,
yeah,
is that a common thing?
the AVL-APC, I mean, I wouldn't say across the nation. Like, for instance, the bull runner data, that was an AVL-APC. That was actually manual counts.
Mm-hmm.
So the same charts, you can create the same charts. It's just, you know, differences of on and offs,
Gotcha.
and then time slots. So you could, that was one of my purposes too, with showing the bull runner and then the HART data, because the bull runner is not the APC data. That's manual counts, and it only has, I think, on and off and time and a number of people. That's it. So you could still, yeah, you could create them with less data.
Okay, great. Any other questions? Well, our session is out of time here. We're going to need to clear the room for the next group coming in. But I do want to thank everyone for your active participation in the session this afternoon, and particularly want to thank our 4 speakers. Some really, really interesting presentations here this afternoon, and I want to thank you all for taking part. Let's give them all one more round of applause, please.